Alrighty, so let's have a look at how we can calculate the parametric form of a function. So, up until now, you have been doing functions and you've been learning about relationships between only two variables, and there have been the x variable and the y variable. But often, and more commonly in the real world, we will have things that have 3 or 4 or 5 or 6 or 7 or an infinite amount of variables. Generally, we're just going to look at introducing 3 variables into our function, and we call this parametrics. So, an equation of a function involves x and y is called a Cartesian equation and can be graphed on the number plane. A Cartesian equation can be also written as a pair of parametric equations x and y, where both are written in terms of a third variable called a parameter. So for example, you've got a cricketer in the SCG and he hits a ball for a 6. A cameraman who is directly behind the path of the cricket batter will only see the rise and the fall of the ball. He won't see the horizontal path of the ball. So the cameraman might calculate, or he might get a computer to calculate that his equation is of the motion y is equal to minus 5t squared plus 25t. Meanwhile, a drone that's filling the horizontal part of the plane might only see the horizontal path of the ball and not the vertical. And he might come up with an equation that says x is 16t. So we have what we call two parametric equations, the vertical and the horizontal. Now these two equations define the movement of the ball with respect to a third variable time in the x direction and the y direction separately. So these two equations are telling us how does time affect x individually, how does time affect x individually, but also how does time affect y individually. Now we can combine these two by making t the subject of one of these equations and combining the two equations to create a parametric equation. So, parametric equations to Cartesian equations. So to change a pair of parametric equations to a single Cartesian equation, we must eliminate the parameter by then solving simultaneously. So generally, we always are going to make t, or whatever the letter is, the subject of our x parametric equation. So if we subtract the 1, we get t is equal to 1 minus x. We then substitute that t value into y equals t squared and get y is equal to x minus 1 squared. This is what we call the Cartesian equation. These two are our parametric equations. Same idea here. If we make t the subject, t is equal to 3 over x, we can substitute that into y and get y is equal to x on 3 minus 2. Feel free to pause the video and try and get the same idea as me, if you can't do it that quickly, which is fine. Same idea in question number 5, where got q is equal to x over 2. So we substitute in our q and get y is equal to 4 x on 2, all squared, plus 8 times by x on 2. Now we can simplify that. Have a go, maybe pause it and have a go at simplifying that. You're going to get x squared plus 4x. That's our Cartesian, not 4y. 4x is our Cartesian equation. Skip this one. I don't know why I put it in there. We'll learn about that next lesson. Linear functions can be represented as a pair of linear parametric equations. So we talked about that. We may be able to interchange equations between parametric and Cartesian forms. Now to sketch parametric equations, we first must convert it to a Cartesian equation. So if we were to convert this to a Cartesian equation, you'll get p is equal to x minus 4 on 2. Substitute your p into y and you'll get y is equal to x minus 4 over 2 minus 2. Now I didn't leave you much working out, I'm sorry. That can be simplified to be x minus 4, and each of them individually on 2, minus 2, which is x on 2. 4 on 2 minus 2 is minus 4. So that's just a nice little straight line. So that's going to be 8, and that's minus 4. So that is the graph of that. If you're unsure how quickly I found the x-intercept, have a go at pausing the video, find the x-intercept. Same idea here. T is going to equal x over 3. So y is equal to 2 x on 3 minus 3, which is y is equal to 2 on 3 x minus 3. That's just a straight line. Intercept at minus 3, and then we're going to have 4.5 as our x-intercept. Again, have a go at pausing the video and finding the x-intercept if you can't do it as quickly as I just did. Now we can also go back the other way. So to convert y equals 3x plus 1, we're going to convert it into a pair of parametric equations. Now we can convert it in many different ways. For example, we talked about time before. You might convert it and you want to know the relationship in chemistry between mass and reaction time and energy produced or something like that. We can have many different ways of defining our parameters. So we can't just convert between this and parametrics without already being given, like we are in these questions, a parameter. So we need to be given a parameter to have a pair of parametric equations. So very easy for our x coordinate or our x equation. It's just x equals p for part A. We're told that in the question. Then we need to substitute x equals p into our y. So 3 times by p plus 1. Those are my two equations there. Same idea here. My x is t plus 2. And my y is going to be 3t plus 2 plus 1, which is 3t plus 7. Same idea here. X is equal to 2q. Y is going to equal 3 times by 2q plus 1, which is y equals 6q plus 1. And those are your two equations there. Okay. Similar idea here. We've got x is equal to 4t, and then we're plugging in x equals 4t into our equation. So 5 times by 4t minus 2y plus 1. Have a go at pausing the video. If you rearrange that, you're going to get y is equal to 20t plus 1 over 2, which you could express as 10t plus a half. And again, it's here we've got our first equation. For our first equation, we've got x is equal to 2p minus 3. We substitute that into our Cartesian and into our Cartesian equation. We have 5 times by 2p minus 3 minus 2y plus 1. If you have a go at doing that, I'm just going to quickly do it now. You're going to have y is equal to, what's that? 10p, what's that? Minus 14 over 2. So y is equal to 5p minus 7. Those are your two equations there. Awesome. Okay. I might go back up. Sorry if you didn't get that down. Okay, quadratic functions. A quadratic function can be represented as a pair of parametric equations, so same as what we just did before. There will be one quadratic and one linear parametric equation to form a quadratic Cartesian function. So we're going to find the Cartesian equation, so we're going from parametrics to Cartesian. Again, we make p the subject, so p is equal to x on 2. So y is equal to x on 2 all squared minus 3, which is x squared on 4 minus 3. Again, we make p the subject. P is equal to x minus 1. So y is equal to x minus 1 squared minus 3 times x minus 1. Now, if you have a go at doing that, you should have x squared minus 5x plus 4. So those are your Cartesian equations for those ones. Oh, and if we graph these, if we make that equal to 0, squared on 4 minus 3, we're going to have x is equal to plus or minus the square root of 12. So that's like 3.4, I think. And we're down here at minus 3. this is the parabola. We solve that x minus 4, x minus 1, so x is equal to 4 or 1. So 1, 4, and we have a y-intercept of 4. So again, we can't graph, or I guess we could graph those two parametric equations, but generally when we're asked to graph form of parametric equations, we first up need to find a Cartesian equation, and then we can graph it. We already did that one, so I don't know why it's there again. Question number 3. Convert the quadratic equation y is equal to x, 2 minus x into a parametric equation. So again, first up, when we're going from Cartesian to parametric, our x is usually always the one that's given. So we've already done half the question because it's given it to us. Then we just need to substitute x into our equation, so minus 2p times by 2 minus minus 2p, which is minus 2p, 2 plus 2p, which is minus 4p minus 4p squared equals y. And those are my two parametric equations. Let's do that for the second one. Substitute in, we've got y is equal to t squared plus 2t, 2 minus t squared minus 2t. Let's have a go at expanding that. So we'd FOIL that out, we get 2t squared minus t to the power of 4 minus 2t cubed plus 4t minus 2t cubed minus 4t squared. So if we simplify that, we're going to get minus t to the power of 4 minus 4t cubed 2t squared minus 4 minus 2t squared plus 4t equals y. Awesome, and those are my two Cartesian equations. Sorry, my two parametric equations. Right, so that's all we did in that lesson. What I need you guys now to complete is exercise 7, I think it's 710. Let me double check. 710, and I need you to do all the questions except ones with trig, like sine, cos, or tan. So if you see any questions with sine, cos, or tan, please don't do them. Alright, I hope that makes sense.